Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to start with the introduction of linked list. Okay, so there are three types of linked list: singly linked list, doubly linked list, and circular linked list. And the singular linked list is used in implementation of some data structures. Okay, especially hash map and hash set. Okay, now the doubly linked list is used in the music player undo and redo operation. Okay, so because we will use the single linked list because of its property, like it can go to the next and the previous address. I will tell this in a detailed manner, just wait. And a circular linked list, it is used in the CPU scheduling algorithms. Okay, now just listen carefully. The single linked list is represented by, see here, there's a node, okay, which contains a value and an address. So this is called what? Node. Now it will be connected with another node. It also have value and the next address, and it also connected to the next node, then next node, then next node, like that. Can I understand this? See here, here is only one arrow mark, right? Only one arrow mark. Here also only one arrow mark. Here also one. Here also one. So this is called what? Singly linked list. It can go only one direction. The singly linked is what? Unidirection. Clear? Now same, same, but only one different is it can go both direction, which is what? A doubly linked list. But how it can go by both direction, we will discuss the structure of the doubly linked list. So in this singly linked list, I have told you we have value and next address, right? Next address. Okay, in doubly linked list we have value, previous address, and the next address. Okay, what is meant by next address and previous address, you may ask. See here, what is meant by previous address and previous address and next address means. See here, in the singly linked list, take for example, there's a three nodes like this. Now take for example, this is 2000, this is 3000, and this is something like 200. We have 4, 5, 6. Now to connect this three linked list, I want to give this next address, this 2000, this address in the next address, so that these two will be connected. There is no connection between them like this arrow mark. They only store what? The value of the next address. Okay, so this arrow mark is virtual, just for our imagination. Now this is 3000, just put 3000, this two will be connected. So this is what? Singly linked list. Okay, here it will be none or null, anything depending on the coding languages. Now in doubly linked list we have three attributes: value, previous, and next. Okay, here will be the previous address, here will be the value, here will be the next. Like this, there are say there are three nodes. Okay, let us take, there are three nodes. Now this is same 2000, this is same 3000. Now this is 200, 5, 6. Yes. Now observe this, whether this node have any previous. No, right? It don't have any previous. It is the first node, right? So it is what? None. Now what is the second and next address for this? It is 2000. So put 2000. While putting 2000, it creates a next address only. It can move in this direction, but we want to move in this direction also, right? Bidirectional. So I want to store the previous address. What is the previous address? 200. So just store 200 here. Can you understand up to this? Yes. Now store 3000 here and then 2000 here, so that both the side there will be a link. Now here it will be none. That's it. It is what? A bidirectional linked list, which is what? Doubly linked list, because there are double arrows, right? So that is a doubly linked list. Can you understand up to this? Yes. Now at last, the circular linked list. Now in circular linked list, it is same as these linked list, but it is in a cycle. Like see here, this is a node, this is a node, and a node. Let us take value, 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 and Take for example, this is 2000, this is 3000, and this is 4000, and this is 5000. Let us take. Now, here it stores 2000. Okay, so that these two will be connected. Now, here it stores 3000, so that these two are connected. Here it stores 4000, so that these two are connected. Here it again stores what? 5000. Okay, this is what? A cycle, a circular shape. So it is called what? Circular linked list. The in linked list there is a term called head. There's a term called head and tail. Okay, but the head is more important than tail. What is my head? You may ask a question. See here, this first node is pointed by this head pointer. This head pointer will point always the first node. It is a reference of the starting of the linked list. We know that if we have this starting point, we can go traverse to all the nodes, right? So that we want this starting point. Yes, in array, look for example, in array, we have 0, 1, 2, 3, 4. By using this 0, we can access the index, right? The first element. And using this 1 and using this 3, we can specifically access the index. But in linked list, we cannot access specifically. We want this head pointer, then we want to move one by one. Okay, so that only this head pointer is so important. And tail pointer is the last node. Tail pointer will point the last node. Can you understand up to this? Yes. So in this diagram, the head will be pointing here. So that I can say in circular linked list, the end of the node, that is the tail pointer, yes, next address will be the head pointer. Yes. So that the last node will be pointing to the what? Starting node. That is the head pointer. Fine. So this is the all three linked list. Okay. Now, what is the major use of linked list? We have seen the individual uses like single linked list, double linked list, circular linked list, like that. But what is the major use? Okay. Let me say let me compare with array so that it will be more clear. See here, it is an array. Take for example, array of size 5. Now here has 10, 20, 30, 40, and then 50. Now, same in a linked list. Okay. In in practice, I will represent a linked list like this. Okay, and I will put the arrow mark so that it will be the next address. I don't represent like this. Okay, it is quite smaller. Now, see here, the important thing in a linked list is memory management. One thing is memory management. I will tell you in next example. This one thing, and another thing is it is easy to insert or delete. Okay, it is easy to insert or delete. You may ask how we can insert or how we can delete. I will tell you. Okay, see here. In this, if I want to delete this 30, how can I delete this 30? I will first remove it. We have inbuilt functions. Without inbuilt functions, how will it do? I will take this 40 and update here. I will take this 50 and update here, and I will remove this 50. And I will mark it as something like called -1 as a end value, like that. So that what is the time complexity of this array? The time complexity will be what? N. Why? Because if I want to take this 10, okay, if I want to remove this 10, I want to swap each and every elements. Each and every elements shift by 1, right? So that the time will be more. Time is more. But in linked list, just observe carefully, just observe. I will take this link away, and I will put another link and connect to this 40, and I will delete this node. Yes, simple, right? I just took and connected. That's it. So insertion is so simple in linked list. Yes, sorry, deletion is so simple in linked list, right? So this is how a deletion takes place in linked list and the array. Now we are going to the important step. You may ask, if the deletion point is at the last, we want to traverse the linked list one by one. Like, just see here. Here it is deletion for the 30. If we want to delete for this 50, we want to traverse from, here is my head pointer, right? We want to traverse from 10, 20, 30, 40, 50, and then want to delete it. So it also take more time, right? It also take more time. Okay, I agree, but in next example, you will be clearly knowing that why we are using this linked list. See here, the linked list is mainly used for the memory management. Like, see here, if This is my array. Okay, this is my integer array. Take for example, the integer size is what? 4 byte. 4 byte. So if the base address is 2000, base address is the first address of the array, the initial address. Now, what is the address of the next block? It is 2004, then next memory 2008, then 2012, then 2016. So this is my obviously my array sizes, right, and array addresses, right. Now, just listen carefully. What are these values indicating? These values indicating that in array we always have continuous address, continuous address location or memory allocation, right? Can you understand it? We want a continuous memory allocation, but in linked list we don't want this. Then how we want this? Just assume we have a array like this, or memory addresses like this. Say 2000, then 2004, then 2008, then 2012, then 2016, then 2020, then 2024, like this. Just assume I'm just putting a small thing. Yes. Now just assume we want array of 5, right? Array of 5, but in this case, see here there is some values, some other values, and here also there is some other values. Now we don't have continuous 5 spaces, right? We don't have continuous 5 spaces. Here are 2, here are 2, here are 2. So in this scenario I can implement a linked list. But you may ask how we can implement a linked list. Just observe, I will take these two addresses. It is next addresses, right? So I will connect this next to here. Then I will connect this next to here. Then I will connect this next to here. Then I will connect this next to here, so that I can get what? A 5. See here, this is a 1, this is 2, then this is 3, then this is 4, this is 5. Like this. Whenever there is not a contiguous memory allocation or memory addresses, we can go with the linked list. So this is called what? Memory management. Hope you understand this concept. Now let us go for the insertion. Okay, just see here. If I have an array like this, and that array have a size of 5 and 1, 2, 3, 4, 5, and same I have a linked list like this. Okay, now I want to insert an element inside this array. Let us take, I want to insert here. Okay, after this 2 and between this 2 and 3, I want to insert 10. Okay, how can I insert it? Because already the size of the array is filled, so I cannot insert it directly, right? So I want to create another array. Okay, I have created another array of size what? 6. 1, 2, 3, 4, 5. Yes, so 6. Now 1, 2, then 3, 4, 5. Then I will insert this 10. That's it. So when we have got the we got the length of the array filled, then we will create a new array, then we will insert it. So this is the case, right? But in linked list, come up with me, I will create a new node of value 10, and I will break this connection. I will break this connection, and I will connect this to here, then connect this 10 here. Now it is automatically inserted, right? It is so simple in linked list, right? So this is what the insertion method in array and linked list. Now tell me whether linked list is quite efficient or array is efficient. Yes, linked list is efficient, right? So in these scenarios, linked list is efficient. But we'll coming to the traversal. We'll coming to the traversal. Okay, in traversal, array is faster. Faster what? Array. Okay, I already told you, right? In array, we can use the index to get the specific value, but in a linked list, we want to traverse. In linked list, we want to traverse. That's all. That's all about the linked list and the array. Okay. Now, I have been telling you that each and every linked list have a node called like this value and next address. What does it mean? Okay, let us come to the implementation. Okay, what does it mean? It means that we have a data type or an object. Okay, inside which we have two attributes. What are those attributes? One is value and another one is next address. I can tell like this, right? It is a data type or an object which have a value or a next address. That's called what? A node. Okay, quite cool. Now, just listen carefully. How can I implement this two attributes? Right? We want to use what? User-defined data types. User-defined data types. Okay. So what we can use? We can use structure in C or C++, structure data type, or we can use class in oops concepts, right? So after this, I will solve or I will give you the each and every logical and how we can implementing in a rough manner. But in code implementation, I will do in a Python. If you want C++ or Java, you may find those in the description. Okay. Now, just see here. I want to use class, right? So just using class. Okay. I will create a class called node. Okay. Inside this class, I will have value and next address as my what? As my data members. So these are what? My data members. Can you understand now? What are these? These are data members. So that whatever the user gives a value for value and value for the next address, I will store them and I will create a individual object. Right? So the blueprint. What is a blueprint? It is a class, right? Class is always called as a blueprint. So what is the blueprint? It is like a value and next address. That's it. By using this blueprint, I will create so many objects, n number of objects. Okay. So this is what the whole thing about the linked list. In next video, in this playlist, we are going to see about insertion, deletion, and in singly linked list and doubly linked list, and also some liquid problems. So just watch till the end. Thank you.